We're now going to learn how to go from mixed numbers to improper fractions and vice versa. So first, a little bit of terminology. What is a mixed number? Well, you've probably seen someone write, let's say, 2.5. This is a mixed number. So you're saying, why is it a mixed number? Well, because we're including a whole number and a fraction. So that's why it's a mixed number. It's a whole number mixed with a fraction. So 2.5. And I think you have a sense of what a 2.5 is. It's someplace halfway between 2 and 3. And what's an improper fraction? Well, an improper fraction is a fraction where the numerator is larger than the denominator. So let's give an example of an improper fraction. I'm just going to pick some random numbers. Let's say I had 23 over 5. This is an improper fraction. Why? Because 23 is larger than 5. It's that simple. And it turns out that you can convert an improper fraction into a mixed number or a mixed number into an improper fraction. So let's start with the latter. Let's learn how to do a mixed number into an improper fraction. So first I'll just show you kind of just the basic systematic way of doing it. It'll always give you the right answer, and then hopefully I'll give you a little intuition for why it works. So if I wanted to convert 2.5 into an improper fraction, or I want to unmix it, you could say, all I do is I take the denominator in the fraction part, multiply it by the whole number, and add the numerator. So let's do that. I think if we do enough examples, you'll get the pattern. So 2 times 2 is 4, plus 1 is 5. So let's write that. It's 2 times 2 plus 1. And that's going to be the new numerator. And it's going to be all of that over the old denominator. So that equals 5 halves. So 2.5 is equal to 5 halves. Let's do another one. Let's say I had 4 and 2/3. This is equal to, it's going to be all over 3. We keep the denominator the same. And the new numerator is going to be 3 times 4 plus 2. So it's going to be 3 times 4, and then you're going to add 2. Well, that equals 3 times 4. Order of operations, you always do multiplication first. And that's actually the way I taught it, how to convert this anyway. 3 times 4 is 12, plus 2 is 14. So that equals 14 over 3. Let's do another one. Let's say I had 6 and 17/18. I gave myself a hard problem. Well, we just keep the denominator the same. And the new numerator is going to be 18 times 6, or 6 times 18, plus 17. Well, 6 times 18, let's see, that's 60 plus 48, it's 108. So that equals 108 plus 17, all of that over 18. 108 plus 17 is equal to 125 over 18. So 6 and 17/18 is equal to 125 over 18. Let's do a couple more. And I'll leave it, in a couple of minutes, I'm going to teach you how to go the other way, how to go from an improper fraction to a mixed number. And this one, I'm going to try to give you a little bit of intuition for why what I'm teaching you actually works. So let's go, let's say 2 and 1/4. You know, if we use the, I guess you could call it a system that I just showed you, that equals 4 times 2 plus 1. 4 times 2 plus 1 over 4. Well, that equals 4 times 2 is 8, plus 1 is 9. 9 over 4. Now I want to give you an intuition for why this actually works. So 2 and 1/4, let's actually draw that. See what it looks like. So let's put this back into kind of the pi analogy. So that's equal to 1 pi, 2 pi's, and then let's say 1/4 of a pi, right? Oh, no, that's not a fourth. 1/4 is like this. 1/4 of a pi, right? 2 and 1/4, and ignore this. This is nothing. It's not a decimal point. Actually, let me erase it so it doesn't confuse you even more. There you go. Okay, so go back to the pieces of the pie. So there's 2 and 1/4 pieces of pie. 2 and 1/4 pieces of pie. And we want to rewrite this as just how many fourths of pi are there total. Well, if we take each of these pieces, oh, whoops, I need to change the color. If we take each of these pieces and we divide it into fourths, we can now say how many total fourths of pi do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 fourths. Makes sense, right? 2 and 1/4 is the same thing as 9 fourths. And this will work with any fraction. So let's go the other way. Let's figure out how to go from an improper fraction to a mixed number. Let's say I had 23 over 5. So here we go in the opposite direction. We actually take the denominator, we say how many times does it go into the numerator, and then we figure out it's the remainder. So let's say 5 goes into 23. Well, 5 goes into 23 4 times. 4 times 5 is 20. And the remainder is 3. So 23 over 5, we can say that's equal to 4, and then the remainder 3 over 5. So it's 4 and 3/5. Let's review what we just did. We just took the denominator and divided it into the numerator. So 5 goes into 23 4 times. And what's left over is 3. So 5 goes to 23 4 and 3/5 times. Or another way of saying that is 23 over 5 is 4 and 3/5. Let's do another example like that. Let's say 17 over 8. What does that equal as a mixed number? You can actually do this in your head, but I'll do it. I'll write it out so you don't get confused. 8 goes into 17 2 times. 2 times 8 is 16. 17 minus 16 is 1. Remainder 1. So 17 over 8 is equal to 2. That's this 2. And 1/8, right? Because we have 1/8 left over. Let me show you a kind of a visual way of representing this too, so it actually makes sense how this conversion is working. Let's say I had 5 halves, right? So that literally means I have 5 halves. Or if we go back to the pizza or the pie analogy, let's draw my 5 halves of pizza. So let's say I have 1/2 of pizza here. And let's say I have another half of pizza here. I just flipped it over. And then, so that's 2. So it's 1/2, 2/2. So that's 3 halves. And then I have a 4th half here, right? These are halves of pizza. And then I have a 5th half here, right? So that's 5 halves. Well, if we look at this, if we combine these two halves, this is equal to 1 piece. I have another piece, and then I have half of a piece, right? So that is equal to 2.5, I guess we could say, pieces of pie. Hopefully that doesn't confuse you too much. And if we wanted to do this kind of the systematic way, we could have said 2 goes into 5. Well, 2 goes into 5 2 times, and that 2 is right here. And then 2 times 2 is 4. 5 minus 4 is 1, so the remainder is 1, and that's what we use here. And of course we keep the denominator the same. So 5 halves equals 2.5. Hopefully that gives you a sense of how to go from a mixed number to an improper fraction, and vice versa, from an improper fraction to a mixed number. And if you're still confused, let me know, and I might make some more modules. Have fun with the exercises.